Good morning, students. Am I audible? Okay. So, like I told you last week, we have started with Unit 2. Okay. And in Unit 2, we have already covered two topics. So, that is text using linked list and queues using linked list. So, today we are going to study another topic that is a different type of a linked list. Till now, you all have studied only singly linked list. Okay. And if you remember in the beginning when I taught you the concept of linked list, we had studied that there are three different types of linked list. Today we are going to study the second type of linked list. Again, the way we do programming is almost same it is in every linked list. Okay. So if you have understood the concept in the first type of linked list, how memory is allocated, what is that next part, how you move the pointer from one node to another and all those things, then programming is easy in this remaining two linked lists also. Okay. Only some things are different, like how, why this second list, why this type of linked lists were made and all. Only those things are what is different. You have to know about. Okay. So today I'll be teaching you a program on a linked list known as a doubly linked list. Okay. So before we study what is a doubly linked list, can anyone tell me what is the disadvantage of using singly linked list? You can type in the chat or you can unmute and tell. Okay. What's the disadvantage of using a singly linked list? I had mentioned it in the beginning when I taught you this topic. If anyone remembers. Yeah, it is unidirectional. So you can go only in one way. You can go from the first node towards the last node. You cannot come back. Okay. You cannot come back. So if you wanted to come back, say from the sixth node back to the fourth node, you could not come back because that arrow, the next pointer, the arrow direction is only in one way. It is in one direction. So it is unidirectional. Okay. So that was the major disadvantage of a singly linked list. So therefore they came up with two other types of linked list, that was doubly linked list and circular linked list. So today we are going to study what is a doubly linked list. So I hope you can see my screen. Can you all see my screen? Someone just type in the chat if you can see the screen. Okay. Okay. So basically this is your program on doubly linked list. Okay, I'll just zoom in. So in a doubly linked list, okay, this is the structure for a node in a doubly linked list. So basically your node will be having three data members. Okay, first data member will be called as previous. It will be a pointer and it will be a variable of this type only, struct dnode of the same structure variable. The second member will be the data member and the third member will be the next member. So basically in a diagram form it will look something like this. Okay, your node will look something like this. It will have three parts. So till now you were studying a single linked list and that node was having only two parts. But if you remember, I told you it all depends on how many members you put here. Okay, if you want more members you can put more members. So suppose I was writing a program for complex numbers. Okay, suppose I was writing a program for complex numbers. So if you know, you have studied your complex numbers, you know that it has your imaginary part and the actual number. So you could have written a int data, then something like float imaginary. So that means your node would have had four parts. Suppose you were implementing it using doubly linked list. Okay. So it all depends on how many members you declare here, that many parts your node will have. Okay. So remember this when you are doing programming in future with linked lists. So now your node will look something like this. previous, data, next. So node will have three parts. This is the structure of a node in a doubly linked list. Again, your node will have some memory, okay, and there will be some pointer associated with your first node. So if I ask you the value of q will be 790. If I want the value of this, suppose here some. Now, one thing to be noted in your doubly linked list will be the first node. Okay, if this is your first node, the previous part of the first node will be equal to null. Okay, the first node previous part will be equal to null. Why? Because there are no more nodes here before that. This is the first node. Okay, and then there will be more nodes present like this. Okay, some values will be there and so on. I'll just draw and show you. Each node will be having some address, say. Again, the node, node next part will have the value 900. Okay, just like a single linked list. Now, this node previous, it will point to the second node will point to the previous node. The previous node's address is 790. So therefore here it will be 790. Okay. The second node's previous value will contain the address of the previous node. So address of the previous node is 790. So here it will be 790. Now since both these nodes are having addresses here, it will look something like this. Okay. Will look something like this. Okay, so that means this node is pointing to this second node and the second node is pointing to the previous first node. Okay, so the doubly linked list diagram will look like this. There will be two arrows, one arrow going in the forward direction and one arrow coming back to the backwards direction. So there will be. So the advantage of this will be if you go to the second node, if for some reason you want to come back to the first node, you can come back because of this previous value. Okay, so everywhere it will be like that throughout your doubly linked list. So this node here, next part will have the value 600. This node in the previous part will have the value 900, address of the previous node. Okay. Last node, next part value will be equal to null. So because we don't have any more nodes at the end. Okay. So this is the way your doubly linked list will be looking. So there could have been more nodes, but this is the general form of your doubly linked list. So there will be some data here, say like this. So this will be the way your doubly linked list will look like. Okay. So remember, whenever you look at a diagram, the way you can make out that it's a doubly linked list, obviously because it will have two arrows like this, one going in the forward direction, one coming in the backward direction. Okay. And remember, the first node of the doubly linked list, previous part will be null. The last node, next part will be equal to null. It will be always the case. Okay. So this thing has to be taken into consideration when you are adding the node at the first, at the beginning, or adding a node at the end. You have to take this null value into consideration. Okay. And there will be one pointer always pointing to the first node. Okay. So any doubts about this, about what I just explained? Anyone has any questions about what I just told about a doubly linked list? Okay. So if you have any question, you can type here, otherwise continue. So basically now we are going to implement the various operations, similar type of operations that we had seen possible on a singly linked list. So we are going to create this linked list, You're going to add a node at the beginning, add a node at the end, add a node in the middle, and delete the nodes. Okay. So basic operations possible on a doubly linked list. All those operations we will learn. Okay. So here, this is your structure of a doubly linked list node. So I declare one pointer here, global pointer q. This q will be always pointing to the first node. Okay. So once I have declared this structure, then there are all these other functions that we'll be looking at. So we'll look at the main function, start our execution of the program from there. Okay. So initially, I do not have any linked list present with me. Okay. I'll just delete all this. Initially, I do not have any linked list present with me, so value of q will be equal to null. Okay, that is the meaning of this. Okay, I do not have any nodes with me, so I initialize the value of the pointer equal to null. Then I want to create my first node, so I call this function create. Okay, when I call the create function, this is the code for create. Okay, I'll give you 2 minutes. I want you to quickly draw the diagram stepwise. You can see the code here. I'm keeping the code open. Draw the diagram stepwise for your by yourself on your books for each of the steps in the in this. You should be able to draw because you have already seen this similar code for singly linked lists. Okay, so quickly draw stepwise. Give you just 2 minutes. Okay. So I'll just solve this. So initially you call this function. Okay. Then you enter the data that you want to store in the node. So suppose the data that we enter is value 10. Okay. So the variable num will contain the value 10. Then we check if q is equal to null. If you remember, we have already initialized q equal to null. So that condition will be true. Q is equal to null. This condition is true. Okay. So we enter inside a if statement and we create our node. This node will be pointed by the pointer q. So we create one node like this. Okay. And q will be here now. So q is no longer null. Q will be pointing to this node with some address. Okay. So in this step here, we have created a node pointed by q. Next step, we make the previous part of the node equal to null. The previous part of the node will be equal to null. The next statement, we store this value, whatever we have taken input. So we had said that value will be 10. We store it in the data part. We store this in the data part. Okay, and then in the last statement, the next part of the node will be equal to null. We make the next part of the node equal to null. Okay. So why do we make the previous and the next part of this node both equal to null? Can you all write in the chat quickly? Why do we make the previous part also null and the next part also equal to null of this node? Yeah, Kaiser, it jumps only in succession. Yeah, you cannot jump from the first node to the third node. You can go only from the first node to the second node, second to the third, and so on. Okay. Yeah. So that's yeah. Because yeah, correct, all of you. Because it's the first node that is created. There is no other node. Okay. It is also the first node and the last node. Yes, all of you have replied correctly. Okay. Now I always see only these 5-6 students typing the answers. The remaining, I don't know, you all don't have a keypad, or you all don't know to use the keypad, or you all are just turning on the mobile and you all are not there. Okay. I only see the 7-8 students always typing the answers. Or you all are just lazy to type, I don't know. Okay. Anyways, we'll continue. So when I exit this function, okay, when I exit this function after executing this, so Q will remain at that node. Why Q will remain? Because Q was declared as the global variable. Okay, so global variables remain. So Q will remain pointing to this node. Okay. So I go back to the main function. So I created my first node. Okay. Now I call the second function. This function will add a node at the end of my doubly linked list. The append will be adding a node at the end of my linked list. So this is the append function. Okay. Again, I'll just give you 2 minutes. Just draw the diagrams quickly for each of these lines. So if you are noticing from the singly linked list, the programming is almost same, except that in this type of linked list, there's a previous part that we have to take care of. Okay. Otherwise, the way we store the data, the way we manipulate the next part and all is almost the same. Only we have to take care of a previous node in this doubly linked list. Okay, like I told you, I'm repeating again, the stepwise drawing of diagrams is an important question in exam. Okay, so please draw it stepwise. I know you can draw it all in one node only, everything, but please do it stepwise. It will become like notes for you for your exams. Okay, so please do it stepwise. Okay, drawn. So let's go to this code. So here again we have declared some local variables. Okay, then I enter a new value to be stored. So let's assume that the value that I'm going to store is 20. So I enter that value from the keyboard. In this line here, I give the address, whatever value is there in Q. Okay, what is the value of Q? Value of Q is 800. Okay, this 800 is the value of Q. I give the value of Q to temp. Okay, 800 is given to temp. So that means in the diagram what happens? Temp also starts pointing to the node with the address 800. Okay, so this is what happens. Next line, check for this. Okay, temp arrow next. If it is not equal to null, then this statement will get executed. If it is not equal to null, but when you check here, temp arrow next is equal to null. Okay, so if it was not equal to null, you would have executed this. But since it is equal to null, you do not execute that. Okay, so you will come here. You will come here, create one new node. You will create one new node. Say so it will be a new node with some address, say, okay, and it will be pointed by the variable r. Okay, as you can see here, the node will be pointed by the variable r. So then in that new node, I'm going to store the value, whatever we had entered from the keyboard. So like we had said, that value will be say 20. So in the data part, we will store the value as 20. Okay. Now without looking at the program also, you can tell me, okay, you can type in the chat. Now, what should come here in the next part of the last node? Next part of the last node should be equal to what? Next part of the last node should contain what value? Should contain the value as null. Correct, correct. Next part of the last node should contain the value as null. So that is what we do here, as you can see here. Okay. So in the exams also, when you are doing programs, you can always draw a diagram like this and do like the way I'm showing you. You don't have to by heart the programs. Okay. So you can just do it like this. It is very logical. It's very simple. So here the next part now will be null. So what is the code for that? For that code will be r arrow next equal to null. Okay. In your diagram it will happen like this. You will get here r arrow next equal to null. Okay. This is not there. Then you have to join the two nodes. Okay, you want to join the two nodes. So here in the previous part, you should get the value of the first node. This is your now second node. So you should get in the previous part the value of the first node. So how you access this part? R arrow previous. Okay. Now if you want the previous node's address, this 800 is stored in two variables. It is stored in either the pointer q or it is stored in the pointer temp. So you could use any one. Okay. So you could have written here r arrow previous equal to q, or you could have written r arrow previous equal to temp, because both of them contain this value 800. So in this program here right now we have taken the value as q, but you could have taken temp. Okay. So understood? So basically I think it is better that you take temp. Okay, I'll just change this.
So only temp will work, right?
Actually, yeah, only temp.
Because Q is only in the first node, respond to the first node.
Correct. That's why I changed it. Okay. Only temp will work. So that's why I've corrected it. Okay. Q should not be there. So Q should not be there in that these two lines. So I've changed it. Okay. So, so what you will do is you will use this code r arrow previous to refer to this part here. Okay. This part here. And you want the address of the previous node. So the address of the previous node, because this is the first node, there are two variables, but in all other nodes there will be just one variable, that is temp. Okay, so that's why I made here temp. So you will get the value of 800 here. So when you get 800, that means this link is formed. Okay, it is pointing to the previous node. Now this first node should also point to the second node. So this null value should get replaced. Null value should be replaced with 450. Okay. So for that we use temp arrow next equal to 450 is stored in this variable r. Okay. So you will say temp arrow next equal to r. So that means here you will get this link and here you will get 450. So you can see here temp arrow next equal to r. Clear? Okay, so this is the way now your first you have created another node. You have added one node at the end. Okay, any doubts in any of these lines of code? I just keep this function open. Anyone has not understood any line of code? See, I'm doing this program a little fast because now we have to start finishing your portion. Okay, and this is now repetition. Okay, the codes are similar to what you have studied previously. So I think you all know it also. Okay, students, what was the last thing you all heard? I think I lost connection briefly. Can someone just tell me what was the last thing you all heard from me? Yeah, Siddesh, we need to use temp. Okay, I'll tell you why we need to use temp. Okay, besides that, any other questions? Okay, so let's go back to the main function. Okay, so say I wanted to call this append function again. Now I've created second node. Okay, so I want to add one more node at the end. Okay, so I call this append function again. Okay, right now your linked list is something like this. When you remember, when you exit this function, append function, when you exit this, r and temp were temporary variables or local variables. When you exit this function, these variables r and temp will be deleted. They will not remain. Okay, only variable that will remain will be q. Okay, keep note of that every time. Okay, so every time the local variables that you have declared will not be remaining, only the global variables remain. Okay, so let me call append again. So when I call append for the second time, okay, I'm calling append. So when I call this append again now let's say I want to enter the value 30. Okay, I want to enter the value as 30. So I give the value of q to temp. So in the diagram I will get like this. I'll get temp here. Okay. Then I check for this condition now. Temp arrow next if it is not equal to null. Okay. Temp arrow next value is 450. Temp arrow next value is 450. It is not equal to null. So what you will do? Execute this line. Okay. Execute this line. The value of temp arrow next is 450 according to this diagram. 450. So that 450 value is given to temp. So that means what will happen to temp? Temp will shift to the node with the address 450. Okay. So because of that, what will happen? Temp will shift from here. Temp will shift from there and come here. Okay, clear? Understood? Now again you check for this condition. Temp arrow next. What is the value? Null. So if it was not equal to null, you would have entered the loop. But since it is equal to null, you're not entering the loop. So you exit this loop, go to this line. Okay. So in this line, you will create one new node. You will create one new node. That node say is this. And it will be pointed by R. So it will be pointed by R. In the next line, you store the data. So you are storing the data. You are storing the data that is 30. Okay. The next line, you make the next part equal to null. Next part will be equal to null. Now you have to join these two nodes. So R arrow previous will be equal to temp, like here. R arrow previous will be equal to temp. So that means here you will get 450 address of the previous node, and because of that you will also get this link. Okay. In the next line, temp arrow next will get a value of R. So temp arrow next means here. Okay. Temp arrow next means here. This will get a value of R. So say suppose the value of R was say this. Okay. The value of R was say 555. So this temp arrow next will get a value of R, which is 555. That means this link will be formed between these two nodes. Clear? And now when you exit this function, these both temporary variables will get deleted. Okay, the only variable that will remain is at the first node, that is Q. Okay, now just to make clear, why do we need this variable at the Q always? Because if we do not have a variable at Q, we can never find the first node and we can never execute any of these lines. Okay, so if you remove these lines, try by removing these lines later when I finish the lecture. Remove these lines and try to add a node at the end and see if it is possible. Okay, if it is not possible, then you will understand the why the significance of this having Q at the first node. Just remove these lines of code which I have highlighted, and then you will understand. Try to add a node at the end, and you will understand why Q is needed. Okay, at the first node. Why we could not have like this more variables present at the any of the nodes. If it was like this, whether we would be able to add a node at the end. Just check for that. Okay, so let me continue. So any doubts about this? Have I been able to answer your question, Siddesh, why we need a temp? Because as you saw in the second node, I did not have any variable like Q or any other variable. So I would not be able to get these addresses. Okay, previous and the next addresses, I would not be able to get if there was no temp present on this node. So because there was temp present on this node and there was R on the last node, because of that I could manipulate these values in the next part and the previous part. Otherwise that would not be possible if I didn't have temp here. Okay, any other questions? Okay, am I going too fast or is it okay with you all? Is the speed okay? Okay, we'll continue then. The next function that will be called in the main will be the display function. Okay, when you call the display function, it will be something like this. What we'll do, we'll again give the value of Q to temp. So that means there will be a temporary variable here, temp. Okay, then this will print a new line, and you will, till temp is not equal to null, you will print all the data in your doubly linked list. Okay, now check for this how it works. Temp value here is 800. Okay, not equal to null. It is true, not equal to null. So you will print the data there. Data that you will print is 10. Then this line here, it will shift temp to the next node. So temp will go to the next node. Already told you how temp is getting shifted. This line we have already experienced above, so I'm not repeating it. Okay. Again, you have checked for this condition. Temp value. What is the value of temp? Value of temp is 450, not equal to null. Okay. So print the value of your second node. So when you print the value of the second node, you print 20, and you will shift temp. Okay. So you will shift temp. Again, check the value of temp. Value of temp is 555, not equal to null. So print the value of that node 30. Now you do this. What is value of temp arrow next? Value of temp arrow next is now null. Okay. Value of temp arrow next is null. So that null value is given to temp. Now value of temp will be equal to null. Value of temp will be equal to null. So when you go back here, when you check for this condition, if temp was not equal to null, you would execute this. But value of temp is null. So you cannot enter the loop. Okay. So you cannot enter the loop. So many of you have the question always, why we cannot do this? Okay, we cannot do that because if this I took this, then my third value would have not got printed. This third value would have not got printed. Okay, you can do that and check. I would have printed only two values, and the third value would have not got printed. That's why it has to be temp not equal to null. Okay. So any doubts in the display function?
Hello, sir.
Yes. Yes, Rupa.
So before the while loop starts, shouldn't temp be initialized to Q?
It's initialized. Here. It's initialized.
I didn't see it. Sorry, sir.
Okay. Any other questions? Okay. Okay. I'll continue. If you have any questions, you can type in the chat and keep. I'll answer all the questions. So we did this display, and then many times we are having this display, so I'll not explain it again. It will work in the same manner. Okay. So then you call this function add at the beginning. Okay. So now we are going to try to create a node, a new first node. So we are already having a first node, existing first node at address 800. Now we are going to try to create a new first node. Okay. So for that we are going to call this function add at the beginning. So this is the function add at the beginning. Okay. So again we are having a temporary variable here temp. So I create a first node using, I enter some value, sorry. I enter a value. So let's say the value that I'm going to enter there will be say 50. Okay. So let's say I'm going to enter the value 50. In the next step, I create a new node. Sorry, not first node. It's a new node pointed by temp. I'll create a new node. Let's say. Remember when just for this new node actually could have been created anywhere. Okay. As you can see here, on purpose, I've given these addresses not in sequential order. Okay. So if I told you, if you remember, I told you nodes are created wherever the memory is free. So the first node was created at memory address 800, second node created at 450, third node at 555. So these nodes need not be in sequential memory locations like your array. Okay. So for diagram, for you to understand, we are putting it in order like this. But actually in your computer, this node would have been first because the address is 450, and this node would have been second. But the links would be like this. Okay. Now if you have to draw like that in that order, you would have got confused. But you have to remember that is the concept of your linked list. Okay. nodes are memory is allocated wherever it is free. So this node, in the way of storage, this node would have been stored first because this address is 450. This node would have been stored second. This node would have been third. But in your doubly linked list, the order would have been like this. Okay. So going back to your program, so we are creating a new node pointed by temp. So again, you give some address, say, and this is pointed by temp.
Okay, sir.
Yes. Yes. Anyone has question? Okay. Then we continue. In the previous part, now this is going to be a new first node. Okay, it's going to be a first node. So this previous part has to be equal to null. We do that using this line here. Temp arrow previous equal to null. This will be null. The second statement, we store the data. So we had said the data that we are going to store there will be 50. So we store there 50. Now you join this first node with this node. So this now will be our first node and this will be our second node. Okay. So you join this first node with this second node. So you have to link them. So to link them, you have to get in this next part the address of your second node. So how you get the address of this node? This address is contained in this variable q, and you access this part by using temp arrow next. Temp arrow next will get the value from q. We will say here like this, temp arrow next will get the value from q. So what will happen? Here 800 will come. Okay, temp arrow next here will be 800. So that means one link like this will form. Okay. Temp arrow next will get the value of q. So a link like this will form. Now what is left? One link. This value should be changed. Okay. So how you access the programming for that? Q arrow previous. Q arrow previous should get what value? 2800. This 2800 is stored in which variable? Temp. So Q arrow previous will get the value 2800 from temp. So you can see here. So you will get here, because of that line, you will get here 2800. So because of that, one link will be formed between the two nodes like this. Okay. Now, like I told you, where should Q always be pointing? Q should always be pointing to which node? You can type in the chat. Q should always be pointing to which node? Q should always be pointing to the first node. So in this case, is it pointing to the first node in the diagram as of now? It's not pointing. So we have to make it point to the first node. So the programming for that is, can you write in the chat what will be the programming? I want to take you to the node with the address 2800. What will be the programming statement for that? Take you to the previous node. So how we take you to the previous node? What will be the programming for that? Yeah, you could have done that. You could have done that. Q equal to temp. You could have done that. Or if someone would say, you could have also done like this. Okay. You could have also done it like this. You could have said Q equal to Q arrow previous. So any one of these two statements you could have used. Okay. But normally we use this. Okay. So when you do that, what will happen? Q will move from this node, and Q will come to this node with the address 2800. Okay. So that will happen in this line. When you exit this function, the local variable that is present, temp, gets deleted and only q remains. Okay, only q remains. So that is the way you can add a node at the beginning. Okay, you have to be very careful when you are assigning these values. Okay, the ordering of the statements are important. If you change this ordering of the statements, the linking may not happen properly. Okay, you can try this later. Just change the order. Take these two statements and execute before these statements, and try. Create a node, and then execute these two statements first, and then these two statements or something like that. Try and see if the linking happens. If the linking happens, then fine, your program is good. But if the linking is not happening, then the ordering of the statements is important. Okay, so before I go to the next function, any questions on this? Look at these lines of code. Any doubt anywhere? Diploma students, if you are not understanding, please tell. Okay, uh, although I told you to see that program, if you are not understanding something, just let me know. Are you all getting, diploma students? Yeah, I think I answered your question, Siddhi Lakshmi. Any other questions? Any other doubts? Siddhi Lakshmi, did you get that answer? Okay. So let's continue then. So we are almost having 10-12 minutes. So let's see how much we can finish. So let's the next function that will be executed in your main will be display function. Now display function I've already explained to you, so it will be again done in the same way, except now there are 4 nodes. In the previous time we had called a display, there were 3 nodes. So now all the 4 values will get displayed. Okay. Next function that we'll be calling will be add after. So this add after will be adding a new, creating a new node at a specified position. Okay, and you can add a new node at a specified position in your doubly linked list. So something similar we had seen in your singly linked list also. So when I call this function add after, this is the add after. So again we have some local variables. We are going to use this local variable LOC to mention the location or the position after which we want to enter a node. Okay. So first we take input from the user for the data to be stored in the node. So suppose the data to be stored says 60. Okay. And say we want to add a new node at the second location. Okay, so we enter here 2. Remember this value. So the data will be 60 and the location position of the new node will be say 2. Next, we assign the value of q to one temporary variable r. So we get here r. Okay, and then we start executing this for loop. So when I start executing the for loop, I is equal to 0. Okay, check for this condition. 0 is less than 2. It is true. So execute this line. So what this line will do? It will shift R to the next node. R will go from this node to the next node. R will go to the next node. I think you all get it, right? The moment you see this line, I think you understand that R gets shifted. Anyone is not understanding and wants me to tell what it is, how you R gets shifted? Yes, Siddesh, your new syllabus is there on the website. You can just go to the website. I think I've told you many times from where you can find the syllabus. Okay, so go to the website and download your 2019 syllabus for you all. Just go to the website and download. So I think all get this line, shifting R to the next node. Okay, check for this condition, is R equal to null. So when you check for that condition, is R equal to null, value of R is 800, is not null. So you do not execute this. Okay, you reach the end of the for loop, so increment the value of I. So now I value will be equal to 1. Check this condition again, 1 is less than 2, true. So again execute this line. So R will get shifted again. R will get shifted to the next node. Okay, check the value of R. If it is null, value of R is 450, not equal to null. So do not execute this. Okay, come back here, increment I. So now I value will be 2, and 2 is not less than 2. Clear? 2 is not less than 2. So you will terminate this loop and go to this line here. Okay. So here in this line, you will shift R back to the second node. Okay. So why we are shifting R back to the second node? Because I want to insert my new node after the second node. Okay. So if you see, this is my first node, this is my second node, and you're going to insert your new node after this node, after the second node. So that's why I have this line here. Just shift my pointer R back to the previous node. Okay. One way of avoiding this line of code, would be to initialize here I equal to 1. So when I initialize I equal to 1, then there was no need to do this. Okay. So all depends on what value you take for I. So since in your textbook they are taken this value equal to 0, I have not changed it. Okay. Now this program is not there in your current textbook, but it is there in one of the textbooks that since I am teaching this subject for many years, so it was there in your one of the previous textbooks. So I have not changed that program. Okay. So if you all want to avoid this statement, you can just make here I equal to 1, and it will work. So in the next line, we make a new node. So we are going to insert one new node down here after this second node. So this will be the first node. This will be the first node. This will be the second node. The new node will be the third node, and then this will become the fourth node. So that is the plan. Okay. So the new node will be the third node. Now currently this is the third node, but now after the new node is added, this will become the fourth, and the new node will become the third node. So let's see how to do that. So first I start by creating a new node pointed by the variable temp. So let's say I create a new node here. Okay. So this will be pointed by the variable temp. Next line, I enter the data. So the data that I was storing there was 60. Now, just look at this diagram and you have to be able to do the programming. Okay. So I want here the previous node. This is going to be your new third node. Okay. So this is going to be a third node. I want here in the previous part the address of the second node. So address of the second node is 800. So what is the programming to get the 800 here? Can you quickly type in the chat? What is the programming? Students, can you quickly type in the chat? Yes, temp arrow previous equal to R. So when you say temp arrow previous equal to R, what will happen? You will get here 800, 800. Okay, so you will, that means a link is formed between this node, and this node. It's pointing to the previous node. Okay, like this. Okay, so it is pointing to the previous node, 800. Now I want to join this node to the next node here. I want to join these two nodes. Okay, so what I should get here? This will be the third node and this one is your fourth node. So what value I should get here? 450. Okay, now if there was one pointer here, say W, okay, the programming for that was very simple. I would have got 450 here by saying temp arrow next equal to W. So that would have got me here 450, and one link would have got formed between this node and this node. But right now I do not have any pointer here. Okay, I do not have any pointer present here. Can you see? But I still want this 450 here. Okay, so I have to come up with some other solution for that. Okay, instead of introducing one pointer here, to make my programming more efficient, I make use of some other concept. Okay, if you look here, this value 450 is already stored in your previous node here. Okay, the value 450, this address of this next node is already stored here. Can I access this value here? I can access this value. What is the programming to access this 450? The programming for that is R arrow next. Okay, so the programming to access the 450 here is R arrow next. So all I have to do is get 450 here. From where I get 450, it does not matter whether 450 comes because of this 450 or 450 comes because of this. All I want is to form a link from the third node to the fourth node. To form a link from the third node to the fourth node, I need 450 here in the next part. Okay, so I get it by using this concept. Okay, so since there is a pointer here and there is 450 here, I know how to get this 450, R arrow next, and here this part is temp arrow next. So I write it something like this: temp arrow next equal to R arrow next. So what will happen? I get 450 here. Since I get 450 here, one link gets formed from here to this node. So that means something like this happens. A link gets formed. Okay, this node starts pointing to the node with the address 450. Clear? Okay, so any doubts about this? Because just let me know. Anyone has any doubts about that line of code which I just told? Okay. Now, I have formed this node from here to here link, from here to here link. Okay. What is left is I need to form one more link like this. What links are missing is, I just tried to show you this. This link is not present. Okay, this link is not yet present. I should have this link. Okay, so that means I should have here 700. Okay, and also I should have, this should be pointing in this direction. Remember, between every node there are arrows going in opposite direction. Now these both arrows in red are not yet present. Okay, so I need to make this both arrows in red. I have to introduce both of these arrows. Okay, right now I only formed these links. I have to delete these two arrows. Okay, which I just highlight this. What I'm just making yellow right now. Those two arrows have to be deleted. That link has to be deleted. These two arrows, and then other two arrows have to be formed, because this will be a second node and this will be a third node. So we have to form these links. Okay, so I want here now this part should be pointing to 700. Okay, so before I make that 700 here, I need to change this. Okay, the previous, this will be a fourth node. This will be a fourth node. It should be pointing to your third node. So if it has to be pointing to your third node, what value should be here? Value of the third node address. So that should be 700. Okay, how do I make 700? If there was, like, again I'll say, if there was a pointer here, you could, it was easy. I would have said W arrow previous equal to temp. Okay, then I would have got here 700. Okay, but I do not have here a pointer, so I need to use some other logic. Now pay attention, this logic you are going to understand for the first time. Okay, look at this line of code here. Temp arrow next, temp arrow next. Okay, where is your temp? Here, temp arrow next means here. I just make it yellow. Temp arrow next. What is the value of that? 450. Okay, 450. So that this part here is value is 450. Go to that 450, this node 450. Of that node 450, take the previous. So you are taking 450 of this part, 450 previous. So that means here 450 previous. Clear? Again I'm repeating this. Temp arrow next. You can see here lot of lines, but the way I'm repeating this, you just write it down. So temp arrow next. What is the value of temp arrow next? 450. So of that node 450 with the node address 450, go to the previous. The address 450 of that previous means here. Okay, that will get a value of temp. So what is the value of temp? Value of temp is 700. So that means here I will get 700. Because I get 700 here, this link gets deleted. Okay, this link gets deleted because now it has to point to the previous node. So the previous node now address is 700. So it points to 700 here. Clear? Now the last, have you all got that? Yeah, it gets deleted. It gets deleted because we are replacing the value. Okay, we are replacing that value, so it gets deleted. Now if I want to delete this link, all I need to do is replace this value. So then this link will get deleted. Now I want this node to get linked to the third node. Okay, so I will say R arrow next means this part. Okay, so just remove this weight. So now I want this part to get replaced with the address of the third node. So if I want that, I will say R arrow next equal to temp, like here. R arrow next equal to temp. So what will happen when I say that? 700 will get stored here. So because it is 700 here, this will no longer point to 450. Now it is pointing to 450. So because it is 700, this link will get deleted and it will start pointing to the node with the address 700. Okay, so this is the way you will add a node in the middle. Clear? So if you do it, it will look the same way like this. Okay, if I would take this node on top now, then it will look in the same way. You are having these two pointers. These both pointers are there. We added one node in the middle. This address here is 700. Okay. So any questions? I'll just keep this code open for you. Any questions here? Okay. Let's do one more part of this add after that needs to be done, and then we can stop. So I suppose I call it for the second time. Okay. We go to this function. Say I enter the value to be entered as 70. Okay. And say I enter the position as 10. Okay. I want a new node to be entered at the 10th position or after the 10th position. As you can see in our linked list, we are just having 5 nodes. Okay, you're just having 5 nodes. So if I cannot enter a new node at the 10th position because I do not have that many number of nodes here. Okay, so I should get an error. So how we get that? We'll see quickly. So first I introduce the value temporary variable into our linked list. So I will get here R. Then I go to my for loop, this for loop. Initially I equal to 0, 0 is less than 10, it is true. So I shift R. So R gets shifted. Okay. Check for this condition, it is not true. Okay. Increment the value of I will be 1. 1 is less than 10, so shift R. R will get so shift R again. When you shift R, you will reach here. Okay. Again check the value of R, it is not equal to null. Increment the value of I will be equal to 4. 4 is less than this. Okay. Right. Try to shift R again. So what will happen? R arrow next is null. R arrow next is null. The value of R will become equal to null. Okay. So because of this line here, value of R will become equal to null. Because R arrow next is equal to null. So R value is null now. It is not this. So when you check for this, is R equal to null? Will come true. Yes, R is equal to null. So you will print this statement that there are less elements. Okay, you can make a better statement, but I have just written it, and you will print this error message that there are less elements, because obviously you cannot insert a new node at the 10th position because you do not have that many number of nodes. So you will print here one message, there are less elements, and you will exit from the function by using this return statement. When you say return, control will directly go back to your main function. So you have called it here, so it will go to the next line. Okay, so that is the way your this loop works. Okay, That is the way your this loop functions. So any questions, students, about this? It's not needed, Siddesh, to keep any more variables, because if you are having 100 nodes, then you will have to have 100 variables. How will you keep track of so many nodes? Okay, as long as your linked list is small, maybe you can have many variables to keep track of the location. But you can insert a node at any location. So suppose you are having thousands of nodes and you want to insert at some particular location, how will you keep track? Okay, so it will not be so efficient having global variables to keep track of locations. You can insert a node at any location. Okay, so any other questions? Okay, so there's one more function that is left for, we'll do it in tomorrow's class.
Sir,
Yeah, yes,
so
it.
I was saying like we can keep a global variable that will keep track of like the total amount of nodes in the linked list. So whenever we add a means add a node, that point means that variable will increase, and whenever we delete it will decrease. So we don't have to just loop every time to get the value of that location to compare.
But how are you going to implement this global variable? How will you keep track? Now suppose I want to insert at the 8th position, I want to insert after that at the 2nd position. So how will your variable keep track of the location?
So whenever we add a function, means in the function no, whenever we add a node, we just increment the pointer, means the variable by 1.
You can try this. You can try this. Right now, I'm not getting exactly what you're trying to tell. You can try implement this code and you can then share it. Okay, we'll see. We'll try to understand what you mean by that. Okay, try this. What you. So, uh, any other questions? Okay. So we'll do the last function, the last operation, that is delete tomorrow's lecture. So I think it's been a little longer lecture today. I think you can just relax for some time and then be ready for your next lecture. Okay.